Can all of you hear me first of all? Just a quick sound check. All right, very good. Um, just going to bring up my slides. Just give me 1 second. So I did not have time to actually record this lecture ahead of time. So I'm just going to do a live lecture, um, and then I will upload the slides to sorry, I will upload the recording to YouTube, and people who are not here can watch it there as well. Um, just going to share my screen. Okay. So today we are going to cover or discuss what is known as the switch statement. And the switch statement allows you to do things that are similar to what you do in if-else blocks. Um, in fact, it's similar to if-else blocks. So there are multiple conditions that you can use or check for. But the advantage of the switch statement is that it is a bit more tidy and a bit more neat to write. Um, and then one of the advantages, so you generally use it in situations where you have to make a series of decisions. So let's say you are looking at a variable, and that variable can take 4 or 5 different integer values, or maybe a few different character values which are not too many. Then a switch statement is a good replacement for um, if blocks. But although it is easier to write, it is neat and tidy, it does have some limitations, and we will look at those as well today and discuss those. Excuse me, just 1 second. Sorry for the interruption. I was getting another call on the side, so I had to take care of that. Um, so generally you use switch statements in situations where you're making series of decisions. Um, you do something similar to if-else statements. Let's take a look at some example code to kind of understand what we're trying to do. So normally an expression for a switch statement looks like this. So that's how you write a switch statement. This is the general expression or general way of writing. So you use the keyword switch. Your expression or the variable whose value you are going to use to make decisions, that variable or an expression containing that variable goes here. So you have parentheses immediately after the switch keyword, and over here you can put your statement. And then you have the body, which obviously is enclosed inside curly braces. Then you basically test for different cases. So you have a variable value here, which could be an integer value or something, and then you test for the case. So let's say case and then one constant value here. So case, so if say you are looking for an integer, the name of the integer is n, then if in case the value of that integer is 1, you can do something in here. If the value is some other constant, let's just say it's 2, then you can do these statements. If it's 3, then you can do something else. And then default is when none of the values in the cases that you have written down, if that is observed, so none of these values is observed. So let's say constant 1 was 1, this was 2, this was 3. So if 1, 2, and 3 are not observed, then everything else falls into this default. So then you go into the default condition, and inside the default body you kind of execute whatever statements you have. So let's look at an example. So it's a very simple example. We have an integer 1 and another integer sum, and we ask um, the user to enter a number. That number basically gets stored in the integer I, and then our switch basically is evaluated based on the variable I. Now if I is 1, we print number is 1. If I is 2, we print number is 2. If I is 3, so in the case that I is 3, we print number is 3. For 4, we print number is 4. And if it's not 1, 2, 3, or 4, then we print something else, and then we execute the program. So it's a very simple way. Think of this as, you could also do this using if-else um, or if-else-if statements. This is something that you could do over there as well. But this looks very nice and tidy. It's simple to write. It looks much more cleaner. It's kind of is easier to understand in this situation. Okay, let's look at a demo example. So let's say I enter a number. So if I enter 2, now my program will go up here. It will print number is 2. Now I would want this to exit and just print this statement. But what I observe here is that I see number is 2, but then I also see number is 3, number is 4, and then something else as well. Now, why is this happening? Because there is one thing that is missing from the previous program, and that is we also have to write this break keyword at the end of the body of each case. So once case 1 ends, we have to write break. Case 2 ends, we have to write break. Because if we do not write break, what will happen is once the program goes into a case, it goes into the other cases that are below it. So it goes in all of these cases as well. So when we entered 2, our program came in here, and then it went into this case as well, and this case as well, and this case as well. So it printed number is 2, number is 3, number is 4, and then something else. So unless you put the break statement here, um, your program is not going to exit the case uh, that it enters. It will go down in cases that follow it as well. So this is something that you have to do. So 3 keywords for the switch. One is switch, the second is case, and then the third is break. So all these 3 keywords, when you combine them, give you a logically correct working switch block, which kind of does what you want it to do. Okay, so now once you actually enter, once you have actually put in the break statements or the break keywords inside each case, then when you enter a number, let's say you enter 3, and then you get only one statement, number is 3. Okay, so let's look at a bit more uh, complex of example, an example which is a bit more uh, involving. So this is the example from the book. The previous couple of examples I took from online. because they were simpler. But let's say, let's look at this example. Now, what does the book example do? It counts letter grade using the switch. So it is going to count. So how many times you enter the A grade, how many times you enter B, how many times you enter C, D, and F. So every time you enter one grade, so every time you enter one grade, every time you enter A, it will increase or increment A count by one. Now, how does this work? It says enter letter grades, and then it says enter EOF. Now, what is EOF? EOF basically stands for end of file. Now, end of file character can be different for different operating systems. On Windows, end of file is generally represented using a control plus Z. So if you press control key and then you press the Z key, that generally corresponds to the end of file. So it corresponds to the EOF character. Uh, on Mac, on Linux, I think this is different. I think on Mac and Linux, EOF basically corresponds to control plus D. We have that a few slides down the line, so we will look at that, exactly what that is. So once you actually enter this control plus Z, if you are entering using Windows, then your program should actually exit. So we have an integer which we call grade. Okay, so this basically represents one grade. Now let's look at this. Now what does our program do? Well, first of all, we put the switch statement inside a while loop. Now, what is this while loop doing? While loop is basically based on the value of the grade. Um, and as long as the entered grade is not equal to end of file, the while loop will keep repeating. Okay, which means that your switch statement, whatever your switch statement contains, it will keep repeating. Okay, now how do we get the grade? We are using this method called, sorry, this function called get char, and then you see you have these two parentheses. This basically means a get character function. This get character function is a C library function, and it is included in the stdio header file. So you don't need to import or include any header file to use this function. This is a function that is provided to you already. So every time a user um, types a character and presses enter, every time the user actually presses any key on the keyboard, the get character will just take that character uh, and input it to your program. So every time the user presses a key, it could be any key. In fact, it could even be the enter key. It will take it and it will put it inside grade. Okay. We're calling grade integer um, because remember that all characters on your keyboard are from the ASCII table, and characters are basically stored as integers, so you can put them inside an integer variable. Okay, um, so let's see, what do we do in the switch? In the switch block, we are basically taking our decision based on the variable grade. So what is input to um, to the program using this get character function. Now we then start with the body of the switch statement, and our first case is capital A. Now if the grade that is input or the key that is pressed corresponds to capital A, or it corresponds to small a, so if we put two case statements right next to each other, that means that there's nothing in between them, and they will exit, the compiler will expect them to have the same body, which is down here. Now what that means is when the user enters either a capital A or a small a, you will go inside this and you will increase the value of a count by 1. So your number of a grades increases by 1. And then your program will break. Once it breaks, what that means is you are coming out of the switch statement and you're coming down here. When you're coming down here, because you're inside a while loop, you are going to go back up to the while loop. So you go back to the while loop, and then the program will check, okay, what is the next key that the user pressed. Now, if the user did not press Control Z and enter, then it will again see, okay, what grade is entered. If it is A, it will increase A. If it is B, if it is capital B or small b, number of B's will be incremented. Similarly for C and for D and for F. Now, one more thing. Um, you are also adding cases for new line. So whenever user presses enter, whenever user presses tab, or whenever user presses the space bar, what do you want the program to do? You want the program to do nothing. So you just want it to come out of the break statement and then again go and do another loop. So your program is going to keep repeating until and unless the file uh, end of file character is entered. Okay. Now, what is our default value? So in case we don't get one of our letter grades as input, or if we do not get any uh, \n or \t, then what our program is going to do is going to print this string incorrect letter grade entered. So if you enter something other than A, B, C, D, F, and then these characters, if you enter anything other than that, let's say you enter the character X, you press the key W, you're going to get this message: incorrect letter grade entered, because your letter grade can only be one of 5 values. So if you press any other key, you're going to get this message, and it is going to ask you to enter a new grade. Okay. And so finally, what you will see in your program is outside of the loop. So whenever the loop stops executing, you're going to get, okay, total for each letter grade R. So you're going to see the number of times A was pressed, the number of times B was pressed, C, D, and F. So you will get a count of the number of letter grades of each type that was selected or entered by the user. Okay. Now this is a bit more complicated example than the previous one. It has a lot of elements to it, so we will look at those one by one. I have discussed most of them, but there are still a few that will come up in the next few slides. So here is a sample run. So how does this program work? It shows you enter letter grades, and it says enter EOF character to end input. So user enters A, B, C in lowercase, then he enters C and A in uppercase, and then a few more grades. And then let's suppose you enter something else. You enter E. So as soon as you press E, it says, okay, incorrect letter grade entered, enter new grade. So you need to enter a new grade, and then when you enter these, and then finally once you press Control Z and enter, um, it displays total for each letter grades, and it counts the number of A's, which in this case are 3. So 1, 2, and then you have 3 A's, you have 2 B's, 3 C's, and then 2 D's and 1 F. So this is a sample output of this program. Okay, now let's look at this statement in a bit more detail. So what is the get char? So the getChar function, every time a key on your keyboard is pressed, it will return that character and it will put it inside your grade variable. Okay, so that's what this does. So getChar, every time the user presses a key, that character is going to come up and it is going to get stored inside grade. Now, if that character happens to be end of file, then your while loop is going to exit. Otherwise, it will keep repeating. And so it's part of stdio.h, so we don't need to uh, include any header files. One more thing, I told you already, we're using, or our decisions are based on an integer grade, even though we are inputting characters. So because C language stores characters as integer values, um, that's why this program still works. So even though grade is an integer variable, you can use it to make decisions about um, characters, because C automatically converts characters that it gets into integers. So for example, if you look at the character A, its integer value is basically 97. Now 97 is the integer representation of the character small a or lowercase a, and you can actually go and check this in the ASCII table. On the ASCII table you will actually see that the integer value 97 corresponds to the character small a. So this is something that C kind of takes care of automatically. So if you print this character, so here in this statement, let's just say you have, um, if you print the character um, A, you use the percentage C. So this is your character representation of lower a. So if you use the percentage C, which is associated as a delimiter for characters, that will show up, it shows up here as a, it actually is. But if you represent that as a percentage D, so if you represent that as an integer, it will appear here as 97. So if you convert, basically what that means is if you convert this character into an integer, then its integer value is actually 97. Okay, and you can see that you've already talked about the ASCII table. So this represents things in the ASCII table. Okay. Um, right. Yeah, this slide contains some information which is kind of useless. I don't know how it is related to the program. You can read this later. It doesn't make much sense. Um, and as far as EOF is concerned, we said that EOF basically, in terms of integer values, it is normally associated with a value of -1, right? But this can change from one operating system to another. So, you know, for EOF, you should not be using the integer value of -1, because that can result in problems once your code is executed on different operating systems or different platforms. So generally just it is recommended that if you're going to use EOF or end of character, end of file, then use just the EOF symbol, because that works exactly the same on different platforms. So preferably use that, not use -1. And this part is telling you, okay, entering the end of file indicator, In Unix and Macs and these machines basically is Control plus T, whereas on Microsoft Windows it's Control plus Z. So it kind of varies or is different from between Windows and other operating systems. Um, okay, so let's move on. Maybe we've talked about switch statement details, the keyword switch you are familiar with. Now, this will contain what is called your controlling expression. So inside the parentheses, you will have your expression. Um, and I will talk about this in a bit more detail on the next few slides. And I've told you the break statement basically causes the program control to continue or move to the first statement after the switch statement. So break will basically make your program exit or leave the switch block. Okay. Um, let's look at the flow chart. So this is basically break is. Um, if you have case A and it's true, your program causes a certain action, and then it has a break statement and it kind of comes down here. Now, if if your statement is true and you do not have a break statement, then it will come down here and execute all statements that follow it. So including the default action. So you don't want that to happen. That's why you have to execute the break statement. You don't have to put a break statement after the default because default is generally the uh, last part of the switch block. So if it is executed, it will be executed at the end and there will be nothing after it. So you don't need to put a break uh, inside the default part. Okay, and what about this part? Well, I said that we need to ignore new lines and tabs and spaces. So whenever a user presses A and then after A, naturally the way that we deal with computers, we generally, so when we say enter a grade, the user is going to uh, select a grade, maybe A, B, maybe C, and then press the enter button. Now, when the user presses the enter key, what generally will happen is your loop will actually execute twice because your loop is based on the get character function, and your get character function is taking or giving your program all character keys, all keys that the user is pressing on the keyboard. Now these include your enter key and your space key and your tab key. Now, because these do not correspond to any grades, and these are also not things that you would want to put in the default case where you are telling the user, well, the enter key is wrong, you should not use the enter key. That's why you want the program to do nothing when these keys are pressed. So you just want it to break and then go back to the while loop and then execute again. So every time the user presses enter, get character is going to give you um, two characters. So your loop will run two times. So the first time, let's say the user enters A and then he hits the enter key. This will go into the switch statement first. So these are two characters. So get character is going to give you A, and you're going to go into your switch statement. You're going to plus plus your A count, and then you're going to come back after your loop. Now, once you actually get to this part, now this part is the backslash n. Now you don't want the program to actually count this, so you just put a special case for this, and you just tell it, okay, just ignore this and repeat again. And next time the user will enter some other character, let's say they enter C, again you will increment the counter for C, and you will not do anything for the enter key. So that part is ignored. So this basically just takes care of that. Okay. Um, so one last concept about the switch block, and this is one of the limitations of switch to some extent. With switch, your expressions have to be constant integral expressions. So each case can only test and will only work when the thing that it kind of gets as its input is something like integer. So it's a constant integral expression. So if it's something like a floating point value, then it will not work. So this is one of the limitations of the switch statement. Now, if you look at maybe if statements and if else statements, they're not really limiting you to just integer values. You can use them to work with floating point values as well. But that's not the case with the switch statement. So the switch statement is mostly limited to dealing with integer or values that can be converted into integers. Okay, so let me show you an example. So let me go back to the example. So one of the limitations is that switch expressions must evaluate to integral values. Now, what are integral values? Integral values are variables of type integer or int, bool, which again bool can be true or false, which means it has two integer values. It can have two integer values, 0 or 1. And again, character as well. So it can deal with characters too, right? Because characters can also be converted to integers, or they have integer values corresponding to them, or essentially they are stored as integers. So these three data types, int, bool, and character, belong to integral value or are integral data types. And so switch expressions are generally limited to working with these kind of data types. Now, if you have non-integral values, maybe float, maybe string, then you cannot use them, at least in C, you cannot make them work inside a switch statement. So the decisions of a switch cannot be based on strings or non-integer values like floats and stuff. So here are some examples which are valid switch expressions. Uh, let's suppose a is an integer, then switch, and then this switch a is obviously valid. You can write maybe addition of 3 characters or 3 integers. That's also valid. You can write maybe an expression which compares two integers but gives you an integral value in return, right? Because if a is less than b, it will give you 1. If a is not less than b, it will give you 0. So these are valid switch expressions. Now let's look at some invalid switch expressions. Uh, if you write something like a is switch and the decision is based on a plus some floating point values, then this will not work. Probably will get a compiler error. If you have a floating value f, then again this will not work. If you have a string and you're using that string to make decisions in a switch, that will also not work. So it has to have either integers, Boolean, or characters. So expressions have to be integral data types, or they have to be expressions that return integral data types. You have similar limitations for constants. So constants, which are kind of based on either integers or characters, or or which are Boolean values, will work, um, but constants that are floating point numbers, which are strings, uh, will not work. And let's say you try to put a case on multiple constants, that will also not work. So these are things that you want to remember. Um, and one of the key differences between characters and strings is that characters generally are enclosed inside single quotes, just like this one here, whereas strings normally are enclosed in double quotes. And so that's the key difference between characters and strings. So remember that. Don't start using double quotes. If you're using characters, use single quotes. So that pretty much is it as far as the slides are concerned. We will start with the do while statement next time. Now I still have a few minutes left. So what I want to do is maybe show you a quick demo of um, the switch statement. So what I have done is I've put my program here. So this is your code from the book example. So let's quickly run this and see if it works. So it says enter letter grades. So I enter A, maybe small c, small a, capital D, small d, then enter. And then if I press Control Z and enter, what happens is my program terminates. It says total for each letter grade. So I have 2 A's and then 0 B's, 1 C, 3 D's, and 0 F. So seems to be working. Okay. Um, one more thing that you could do is um, you can also, because this is get character. So let's do one more test. So let's test one more thing. So let's say I enter A, and then I enter a character which is not a letter grade. So let's say I enter P. What does the program do? It says incorrect letter grade, enter a new grade. If I don't enter anything, if I just enter a blank, so if I just press the enter key multiple times, it does not do anything. So it just ignores that, right? It does not count it as letter grade. It just keeps asking me to enter something else. So let's say now I enter small a, press enter, and I press maybe uh, F, enter, and then when I press Control plus Z and enter, now it says okay, total. So I have 1, 2, 3, 4 A's, 0 B's, 0 C's, and then 1 F, right? And so it gives me the correct count of everything. So it seems to be working fine. Now, another way that you could enter data here is, because there is really no requirement for you to enter. Every time you press a key, it will be counted. If it is a valid grade, it will get counted. So let's do one more experiment. You could do something like A. So you have multiple A's that you have pressed. You could press C, C, and if you do something like F, F, so you're not pressing enter at any of these times. And let's say you press Control Z and then enter. Um, what did it say? Incorrect. Okay, maybe I pressed some other key. Okay. Now what does it do? It counts 6 A's, so I have 6 A's and then 2 C's and 2 F's. So it doesn't really care if I entered any, if I press enter after inputting a grade. So every time I press the letter A, it will count that as a grade A. So I'm not really required to press enter. It's just the program makes me feel that way, but I don't have to. If I just press the key, it will still count it. Let me repeat that one more time. So let's say if I just exit the very first time, it also exits. Okay, so this is a nice way of looking at things. Let's do one more experiment. Let's try to make this float and see what it does. Do float, and there you go. You immediately see that you start getting these warnings and errors under inside the switch statement. It starts telling you expression must have an integral or enum type. So because you weren't using a grade here, now let's say you make this char, then it should work. It also works when you're using char. Let's do that experiment. So if I just use char, it also counts. It works as long as this is an int or a character, it still works. So I can make this an integer as well. Okay. So this is something that you want to remember. Um, what else could we do? I still have one more example that I would like to show you guys. Let me quickly open it. So if I go back to my if statement and I load that, so this was the demo of the if statement that we if else statements that okay, this is something different. So this is just the if statement. Sorry, I want to show you the demo of the if else statement. So let me load this. Now what are you doing here? um, you are doing something like score, and then based on score, if score is greater than equal to 90, you do something like you say the character is the grade is A, the grade is B, and then C and D. Now, how would you do this using a switch statement, right? If you did this for a switch statement, well, if you use the simple approach, then that means you have to test for values from 90 to 100. So these are 10 values. So you need to have 10 cases, 90, 91, 92 up to 100. All of these will correspond to A grade. Similarly, for B grade, because you cannot use these greater than equal to things inside your cases, you again have to write 10 cases, and so your case in this type of a scenario becomes really very cumbersome and difficult to work with, right? So if you try to work with it very simply using the switch statement, this seems like a much better way of doing things because it's much more simpler to at least to think about or easier to do than doing things using the switch statement. But there is one way that you can actually accomplish this or do the thing using a switch statement. I'm going to quickly show it to you. I have that here. Just copy paste that. So, this out. Right. So what do I have here? I ask the user, or so actually I'm not asking the user to input anything. This is a simple program. I actually put my grade or number over here, and I calculate the grade based on value of the score. So if the score is greater than 100, then we say, well, invalid value of score, because score can be between 0 and 100. So in that case, our program is going to exit. So it's going to return -1 and it's going to exit. So it won't go down here. But if I want to do this using a switch statement, I can do this. And how I can do this, when I in Node only have 3 or 4 different cases here. I don't have 90 different cases. And how am I doing this? So what I do is I take my score, which is an unsigned integer. I divide that by another integer. If the number inside score is 100, I'm going to get 10. That would be the first case. However, if the number is between 90 and 99, because these are both integer uh, variables, I'm going to get an integer 9, because it's going to drop the decimal values. So if case is 10 or case constant is 9, my grade is A. And then I now if uh, the result of the division in the expression is somewhere between, so if score is 80 and 89, then the result of the division is going to be 8. So I get this because the decimal value is going to be dropped. So I can still do this kind of a problem, but I have to think a little bit more about how I have to do this. So let's quickly run this, because we're almost out of time as well. I'm sure you guys are tired. I am also tired. So grade is C. Now, what was grade? What was the score? The score was 75. When the score was 75, then yes, on 75 I should be getting a C. Okay. Let's try an example. Maybe let's do something like 70. Okay, sorry, I pressed the wrong key. Let's just do 71. Again, I should get C. Yes, I do. If I try 200, it will say invalid value of score. If I try maybe some value like 99, it should give me A. Plus, if I try something like 0, it will give me grade as F, right? Um, so you can accomplish you, with a little bit of effort, you can make the switch statement do stuff similar to almost exactly similar to if else blocks. You can compare the two and think about which one looks better, whether it's this one or it's this one. It really is up to you. But you know, you can do a lot of things with different programs. So that's pretty much it. We've gotten to the end. Thank you to the 13 people who've actually joined the class today. So you don't have to watch the video lecture later. People who are not here, I'm going to upload this shortly. After I download it, I will upload to YouTube and I will share the link with them. Okay. So thank you very much. And I will see you